All right, hello class. This will be the last module for this chapter, and we're going to go over examples of problems that you can expect to perform in your quizzes and exam. Now, we left off finding our angular momentum for an F orbital, right? I'm just going to redo this again because you're just starting the module again. So if we have our L, and we know that we have 0, 1, 2, and 3. We just count up S, P, D, and F. Those are the symbols. So we know for an F, L has to be 3. Okay, now let's go to a more complicated one. What values of our angular momentum and magnetic quantum number or quantum numbers, I should say, are allowed in the principal quantum number 3? So we know that this means n equals 3. So we need to find our L and our M sub L. Well, to do this, we have to see what we have for our L's and n equals 3. To do this, it's easy to use a periodic table. So we're going to go down here. I have one at the bottom so we can scroll. Now, let's label everything. We know n equals 1, 2, 3, 4, 5, 6, 7 here. But let's label our D's. We know it starts at 3, 4, 5, and 6. And if you didn't remember that from intro, it starts one behind. We'll talk about that again in the next chapter when we do electron configuration. And then here we have 4 and 5. So if we want n equals 3, we want what L's? Well, we know in n equals 3, we have to have an L of 0, which is an S. We know for n equals 3, it goes this way as well. 1, 2, 3, 4, 5, 6, all the way down. So we have this n equals 3. So we know we have P's. We know we have an n equals 3 for our D's. That's there. So we have an L for our D's. But is there a n equals 3 for our F's? There's not. So there's no n equals 3 for our F's. So that means we only have S, P's, and D's for our L's. Okay, so our L will only be n equals 3 here, 3 here, 3 here. F doesn't have a principal energy level that starts at 3. It starts at 4 instead. So let's go back up here and write that down. So we know that our L could be 0, 1, and 2. Our S, our P, and our D. Okay, so that's what our L's can be. Now, what about our M sub L? Well, this is where it's the amount of orbitals we have and the orientation, right? And with M sub L, you start at minus L, go through 0, and then end at plus L. So we have to write all of this out. If it's an S, we have 1 orbital. If it's a P, we've got how many orbitals? Let's take a look at our periodic table. I just wrote 3. But over here, here's our P block, right? And we talked about there being 1, 2, 3, 4, 5, 6 columns, 6 electrons, but that means we have 2 electrons in each orbital. So we have 3 orbitals for our P's. Okay, so let's go ahead and do that. So if we have our P here, we have 3 orbitals, and then what are our magnetic quantum numbers? We'll put that in later, but we just want to write the orbitals for now. So we have S, P, and D for n equals 3. Now, what about D? How many orbitals do we have in D? Let's go back down and look at D. So D, how many columns? We have 10 columns. That means 10 electrons, 2 electrons in each orbital. So that's 5 orbitals for our D block. So let's write 5 lines. 1, 2, 3, 4, 5. So the lines, again, if you don't remember from intro, those represent your orbitals. Now let's assign our M sub L. So for S, it just is your L, right? There's only 0. So S's always just have 0. So I'm going to go ahead and just squeeze in the 0 there. So our M sub L is 0. Here to make it better, let me write it up higher. So there's our S. It's 0. So this is our S orbital. Now our P, we know P's start with 1. So it'll be minus 1, 0, 1. So those are the M sub L's. So all of these will represent our M sub L's. And then D, we know it starts at 2. So it'll be minus 2, minus 1, 0, 1, and 2. Okay, so what values of angular momentum do we have? 0, 1, and 2. This would be our answer. And what values of m sub l are allowed in the principal quantum number? So this is your answer. So you would draw the orbitals, and you would make the symbol for S, it would be 0, P minus 1, 0, 1, and D would be minus 2 to 2. Now, would you have to draw the orbitals here, the lines? You don't have to, but I recommend it if you've not done it before. It makes it easier. Okay, but those are your two answers. Okay, now let's do another problem. How many orbitals are there total in n equals 3? Well, n equals 3 again. We know we've got a 3s. So if we go back here using our periodic table, we've got a 3s, we've got a 3p, and a 3d. So this whole thing is a 3d. Now there's no 3f. So let's go back here. There's a 3s, 3p, 3d. How many orbitals do we have? Well, in S, recall there was just one orbital. P, we had 1, 2, 3 from the prior problem. And D, we had 1, 2, 3, 4, 5. So 5, so 1 plus 3 plus 5, we have a total of 9 orbitals. We have a total of 9 orbitals. Okay, another type of question you could see would be how many total electrons are in n equals 4. So we would have to do the same thing as we did before. So let's look at n equals 4 this time. So I'm going to erase the 3. So now let's look at the 4s. So we know we have S, we have 4s, this region. We have a 4d. We know we've got a 4p. And then here's where we can finally use our f. Here's our 4f. Okay, so we've got a 4s, 4p, 4d, and a 4f. So how many total electrons? So 4s, 4p, 4d, 4f. How many electrons can be in the s? We'll scroll back down to look at this. We know there can be 2. So 2 in the s. How many in the p? 1, 2, 3, 4, 5, 6. Again, it's just how many columns you have. So 6 plus 2 plus your d's. You've got 10 in the d. And then we've got 14 in the f. So again, you count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 in the d's. And then in the f's, we'd have 14. So 2 electrons there, 6 electrons here, 10 electrons here, 14 electrons there. So you would just count all of those up. So here we've got 2, here we've got 6, here we've got 10, and here we've got 14. So we have a total of 32 electrons. So these are some typical problems. Another type of problem you'll see is providing all the quantum numbers for an atom. Now here, let's do all of the 4. So the 4 are our N, our L, our M sub L, and our M sub S. This gives us an opportunity to find our M sub S, the spin. So hydrogen we know is in the 1s. So here's our S block, it's in orange, and the N is 1. So I'm just going to draw one line for it. So here's our S. And we know that hydrogen just has 1 electron. So again, electrons are represented by arrows, and it has an arrow that's up. So we know N is 1. We just found that out. Now the L for S, again, is always 0. And M sub L for S is always 0. The only difference with this one is the M sub S. Here we have an arrow pointing up, so it has to be plus 1/2. Now let's contrast that with helium. Again, helium over here, look at the periodic table. Helium is right here. It's in N equals 1, but it's orange. It's not in the P block, it's in the S block, really. So it's in the S, so its L is 0. So this is still S. So we know N equals 1, L is 0, and we know that the M sub L again has to be 0. But what would the M sub S be? Well, here, helium has 2 electrons, so we've got 1 arrow up, 1 arrow down. And you're looking for this one. It's always the last electron in the valence shell. So if you remember that from the last module, we're always looking at the last electron in the valence shell. So this will be minus a half. Okay, let's look at another. Let's look at nitrogen. So nitrogen, if we find nitrogen, this is going to be over here in our P block. So here's boron, carbon, and this one right here is nitrogen. There's our nitrogen. Now nitrogen's in our P block. We know there's 6 electrons total if you fill them all up, but we just only care about the last electron for nitrogen, its valence electron. So we're going to draw the orbitals first. 1, 2, 3. We know they're the P's, and we know it's going to be a 2p. We know it's a 2p. And let's count how the valence electrons for nitrogen. You just use the column, right? The group number. So there are 5 electrons, but if we start counting just from our P's, we know that for nitrogen, there's just 1. We'll count this one, 1, 2, and we count itself 3. So we're going to put 3 electrons in there. So 1, 2, 3. So if you guys remember from intro, you fill separately first and then you will fill. So here, this electron is in that last orbital. Nitrogen has 3 orbitals because it is in the P block. All right, so our L is going to be 1. And how do I know L is 1 again? How we've been doing it this whole time. So if we have our L's and we count 0, 1, 2, 3, we know S and P is 1. So that's just something that I find it beneficial just to have memorized. Now, how do we do the M sub L's? Well, M sub L, you start with your L, make it negative and count forward. So minus 1, 0, 1. And now we're looking at that last electron again, so its M sub L has to be 1. I hope you guys all understand that. It's its last electron in its valence shell. Now, we don't include the S's here, right? So I know that the valence number is 5 for nitrogen, but we start with we only use 3 of them because 2 are in the S. We only care what's in the P right now. Okay, so then the last quantum number is going to be M sub S. So M sub S is going to be its up arrow, so it's plus a half. So that is going to be plus a half. Okay, so we're running out of time. So let's do something, let's do chromium. Now chromium is going to be in our D block. And over here, if I count 1, 2, 3, 4 over, this is chromium. Now, I already just counted 1, 2, 3, 4. So I'm only going to look at the electrons in the D block. So how many orbitals are in the D block? 5, right? So D block has 5. So 1, 2, 3, 4, 5. Now our N here has to be 3 because recall that our D block starts with N equals 3. It's 1 behind our periods. So N is 3. Our L has to be 2. Our L is 2. And now let's do our M sub L. Well, we can't do our M sub L till we fill in our electrons. We have 1, 2, 3, 4 electrons. So 1, 2, 3, 4 electrons. So if we have these 4, what would our M sub L be? Well, we have to count them out. So it's our negative L, minus 2, minus 1, goes through 0, plus 1, plus 2. And it's fine, we don't have anything here in that orbital. And we only care about this last one here. So it's always the last one counted. So our M sub L is going to be 1. And it's going to be up and positive, so that's positive a half. Okay, I hope that makes sense. All right, well, I'm going to conclude this because I'm running out of time. But in our live lecture, you can ask me more questions. I'll be happy to answer those. We did quite a few problems, and we are done with Chapter 7. Okay, well, we're not done, but the modules are done. Okay, bye-bye.